Good day to you, ladies and gentlemen, and welcome once more to Waffle TV. If this is your first time joining us on this platform, this is a platform where we exemplify, we simplify, and we demystify elementary mathematics for your understanding. In our last lesson, we solved the different aspects of a cylinder, and we promised you that today we're going to look at something new. And in today's lesson, we're going to be looking at an application question on how to solve problems involving cubes and cuboid. Before we delve into the business of the day, we just want to invite you to join us in our initiative to support underprivileged learners in local communities with educational materials. This has been a cause for concern because so many children in local communities need help so that they can equally study like others with privileges and become great people tomorrow. By the end of the lesson, we are going to leave a link where you can join us, view this project, and see how you can be of help. You can equally view more on our website at www.wapfou.com. WAPFOU is WAPFOU.com. Thank you for visiting our website and equally joining us in this project. Now, going to what we have today, we are going to be exploiting a question that has to do with practical life situation. Stay tuned as we move on to see how to solve this problem based on what we learned concerning cubes and cuboids. Now, this is the question we have. It says, a rectangular reservoir is to be painted both inside and outside surfaces. It has the following dimensions. The length is 50 centimeters, the width is 30 centimeters, the height is 40 centimeters. The thickness of the sheet that is used in producing the tank is 2 centimeters. It costs $5 to paint a square unit of the tank. Now the first question is, calculate the surface area to be painted. B, how much will it cost to paint the whole tank? C, what volume of liquid can the tank hold? And D, convert the volume of the liquid in the tank to liters. Remember, we're going to have our answer in cubic centimeters. Now you convert from cubic centimeters to liters. Now let's start from the external surface area of the tank. External surface area. Permit me write external surface area in short as XSA. Length of the external is given here clearly, 50 centimeters. Width is 30 centimeters. And the height is 40 centimeters. The area, surface area, is equal to length times width times 2. We'll not emphasize on this because we learned about this already. Length times width times 2 plus length times height times 2 plus width times height times 2. The next step will be to substitute. We know the length, the width, and the height. Then multiply. So the length here is 50 times width, which is 30 times 2. All this plus length is 50 times height, which is 40 times 2, plus width is 30 times height, which is 40 times 2. If you multiply this carefully, 50 times 30 times 2 will give us 3,000, plus 50 times 40 times 2 will give us 4,000, plus 30 times 40 times 2 will give us 2,400. And if you add all this together, it's going to give 9,400 centimeters square. This is the external surface. We're going to move to the next step, which is the internal surface. This is where there is a trick. Please follow up so that we find the new dimensions of the internal length, width, and height. Now with the internal angles, the length will be different. Length will be equal to 50 minus 4, which is equal to 46. Why are we subtracting 4? Remember, the thickness of the sheet or the material used in making the tank is 2 meters thick. Assume this is our container. It means at this one end, it is 2 centimeters thick, and at this other end is 2 centimeters thick. So this 2 plus this 2 is going to give 4. And if we want to measure in to in, we're going to subtract the 2 centimeters this way and 2 centimeters this way. That's why we are taking away 4 centimeters, and we'll be left with 46 centimeters. We do the same for the width. Width is equal to 30 minus 4, which is equal to 26 centimeters, and the height is equal to 40 minus 4, which is equal to 36 centimeters. Let's now move on to calculate the surface area of the internal reservoir. Surface area will be equal to, same thing, length times width times 2 plus length times height times 2 plus width times height times 2. We get our new length and width and height substituted here. The new length is 46 times new width 26 times 2 plus new length is 46 times new height 36 times 2 plus new width 26 times new height 36 times 2. If you multiply this carefully, 46 times 26 times 2 is going to give us 2,396 plus 46 times 36 times 2 is going to give 3,312 plus 26 times 36 times 2 is going to give a total of 1,786. And if you add this carefully across, it's going to give a total of 7,576 centimeters square. Therefore, total surface area will be equal to external surface 9,400 plus internal surface, which is 7,576, and this put together will give a total of 16,976 centimeters square. This will be our answer for A. So this is the area that will be painted, both the inside and the outside. Now let's go to B. B is asking us how much it will cost to paint the whole tank. Remember, the cost of a square unit is $5. So to paint the whole tank, we multiply $5 by the total surface area to be painted. Let's do that practically. B, area to paint, is equal to 16,976 centimeters square. Cost per unit or per centimeter square is equal to $5. Therefore, total costs will be equal to 16,976 times $5. And if you multiply this across, it's going to give a total of $84,880. So this is what you are going to spend if you are to paint the inside and the outside of this tank as far as this question is concerned. Now let's move to the C part, which is asking us what volume of liquid can the tank hold. The rule to calculate the volume is equal to length times width times height. But we must be careful here because we have two dimensions. We have for the internal and for the external. If they're asking us of the volume, what quantity of liquids that the tank can hold, then we are going to use the internal and not the external. So our internal length 46 times internal width 26 and our internal height is 36. And if we multiply this together, we're going to have a total of 42,576 cubic centimeters. Take note that at this level, our volume is in cubic centimeters and not centimeters squared as for the area. Now let's move to the last aspect, which is asking us to convert the volume of the liquid to liters. So let's take note that 1 liter is equal to 1,000 cubic centimeters. If 1 liter is equal to 1000 cubic centimeters, therefore 42,576 cubic centimeters will be equal to 42,576 divided by 1000. And we learned during our division of decimals that if we are dividing by a power of 1000, we move the decimal place to the left 3 places. So the decimal place falls here. And our answer will be 42.576 liters. Remember, our final answer is supposed to be in liters and not in cubic centimeters. So our final answer here will be approximately 42.576 liters. Let's move on to our second example for the day. Our second example reads, the edges of a cube is 3 meters long and a cuboid is 4 meters by 3 meters by 2 meters. A, which of these shapes can hold more fuel? And B, what is the difference in their volumes? A, volume of cube is equal to side times side times side. And if we substitute, it's 3 times 3 times 3, which is equal to 27 meters cube. Volume of cuboid, which is equal to length times width times height. Length is 4 meters times width 3 meters times height 2 meters, which is equal to 4 times 3, 12. 12 times 2 is 24 meters cube. Therefore, if you compare these two, you realize that 27 is greater and 27 is for the cube. Therefore, the cube can hold more fuel. B, let's move to the second question. What is the difference in their volumes? Volume of cube is 27 meters cube and volume of cuboid is 24 meters cube. Therefore, difference will be equal to 27 minus 24, which is equal to 3 meters cube. This is what you can do to solve this problem, and as simple as it is, never get scared by the nature of the question. This is what we had for you today, and we believe you've learned something. If you did, consider giving us a thumbs up, subscribe to our channel, and comment so that we can improve on the service. Don't forget to get to the link that we've given in our description so that you can view our project for this year and come in so that together we can support underprivileged learners in local communities. That said, we're going to meet in our next lesson, and don't afford to miss it. It's going to be very interesting. See you in our next lesson. Thank you.